This is AP Calculus 8.7 and 8.8, volumes of known cross sections. We're finding the volume of a specific shape that they will give you, and we're going to separate that shape into known cross sections. And the most common cross sections that we're going to deal with are squares, semicircles, equilateral triangles, isosceles triangles, and rectangles. I'm going to give you a couple other formulas as well, but the ones I just mentioned are the most common. And I find the most difficult part about this is trying to visualize what they're asking you to find. So I wanted to show you a few pictures that kind of explain what it is we're finding, and then we're going to get into how to set these up. And once you get them set up, it's really pretty easy to solve. So here I have a 3D shape, and notice this axis right here is the x-axis. This axis right here is your y-axis, and the axis going up and down is your z-axis, making this shape 3D. I'm going to draw around this shape that it is that we're looking at so that you can understand what is the part that would be graphed. So what they're going to do is ask you to graph one or two different equations on the coordinate system. And so you're going to graph that flat plane on the XY axis. And so what I've done here is it looks like I've got two straight lines. I've got this line here and I've got this line here. And what this problem probably said is that you've got rectangular cross sections, and those cross sections are perpendicular to the x-axis. This right here is a rectangle. And if you think about what we've talked about with Riemann sums, weren't we talking about the area underneath the curve? And we said that if we separate that area into rectangles, we can estimate the area under the curve based on what those rectangles are. And the thinner those rectangles are, the more accurate our area under the curve will become. Well, the idea is the same here. What we're going to do is we're going to put a cross section of a common shape on this graph. We will know the length of one of the sides of that common shape because it will span the entire length of our 2D graph. And then the idea is if we separate this thing into an infinite number of that basic shape, then we can take the integral of that 2D shape from A to B and find the volume of what is formed, or the shape that is formed, using that cross section. In this one, it looks to me like the graph was a parabola, okay, and then this diagonal line going from where those two things intersect, and it looks like the cross section here is an equilateral triangle. So I've got some more pictures to show you, and these are good visualizations. I think that's the hardest part of this, is being able to visualize what it is you're finding with these. So with these shapes, this one right here, it looks like we've got a parabola, y equals x squared. They gave us a boundary, A to B, and they said that these cross sections were going to be perpendicular to the x-axis, and it looks to me like these cross sections are little squares, and you see how they've taken the squares and they've made the side of the square represent the distance from the y equals x squared line to the x-axis. This one gives you semicircle cross sections. This one is giving you rectangular cross sections. This one is giving you, it looks like, isosceles right triangles as the cross section. All of these cross sections are perpendicular to the x-axis, and how we set them up is going to depend on whether they're perpendicular to the x-axis or to the y-axis. These are the common formulas that you're going to be asked to use. The area of a square, remember area is side square, so if we're talking about the area being side square, the side of our square is going to be represented by the image that we're finding. If I go back to this slide, this one was a square cross section, and the side of the square was the difference between the x squared curve and y equals 0 line. So if we subtract x squared, the top function, minus 0, we get y equals x squared. So in this case, the length of the side of the square is going to be x squared. And so we have to get these formulas in terms of x and y, depending on whether they are perpendicular to the x-axis or perpendicular to the y-axis. So pause the video, go ahead and write these formulas down. These are the most common ones. So if we know the formula for the area of the specific cross section that they're talking about, we can manipulate our equations so that they are in terms of either x or y. And which one we write the equation in terms of depends on whether the cross section is perpendicular to the x-axis or it's perpendicular to the y-axis. So we can find the volume of the solid having this known cross section by using definite integrals. And the intervals on those integrals are going to be based on the beginning and end of the axis that the cross section is perpendicular to. That'll make more sense in just a minute. So here's your basic setup for these. It says if the cross section is perpendicular to the x-axis and its area is a function of x, we can say that that's said to be a of x. Then the volume V of the solid on the closed interval from a to b is given by volume equals the integral from a to b of the function f of x dx. Now here I have f of x. Up here we said it was a of x. You can think of it either way. It means the same thing. A and b are interval values on the x-axis. Now, so if the function is perpendicular to the x-axis, then your a and b come from the endpoints on the x-axis. So that should help you remember which one you're using, okay? If it's perpendicular to the y-axis, then these numbers will come from the y-axis. And now I've got that down here. When the cross sections are perpendicular to the x-axis, and this is extremely important, we need to solve the equation for y. In other words, we need to get y by itself, and this function will be in terms of x. This is extremely important because if they give you the equation solved for y, but it's perpendicular to the y-axis, you will then have to manipulate the equation and solve it for x. So you have to be real careful. So if it's perpendicular to the x-axis, we need to solve the equation for y if it's not already, and that will help us get our length of that specific side of the cross section. Here it says if the cross section is perpendicular to the y-axis and its area is a function of y or a of y, then the volume V of the solid on the closed interval from c to d is given by, now the volume equals the integral from c to d. Now if this is perpendicular to the y-axis, c and d, the boundaries, will be taken from the y-axis. Okay, technically this would be f of y dy, because if it's perpendicular to the y-axis, we're going to solve the function for x, and it will be in terms of y. So this really should be f of y dy. And then when the cross sections are perpendicular to the y-axis, we solve the equation for x in terms of y. Now, this will all make more sense as we go through the examples, but you just need to get this in your notes. I do think it would be better to change this formula. Let's change that. So I would put V is equal to the integral from c to d of f of y dy, because if it's perpendicular to the y-axis, then we have to solve this equation for x. All right, so let's do a couple examples. The easiest way to learn this is to just do examples and go from there. So I've got quite a few examples. I'm going to work through the first two with you, and then after that, we're really just going to concentrate on the setups, and I'll give you the answers. You can use your calculator to find the answers. You can work through them by hand if you'd like, just to make sure you're getting them right. But the main thing here is the setup. The integration is not that bad. It's stuff that we've done so much. You should be pretty comfortable with that. So we're really going to concentrate on the setups, making sure you understand how to set them up, and then we'll go from there. So the first one says, find the volume of the solid whose base is bounded by the circle x squared plus y squared equals 4. So the 2D shape that has been graphed is the red circle here. That's what they're talking about. And we're going to find the volume of what we get when we separate that circle into a bunch of cross sections. And the cross sections are perpendicular to the x-axis and are squares. Okay, so if it's perpendicular to the x-axis, which you can see here, this is the x-axis, this is the y-axis, my square is perpendicular to the x-axis. And the idea is we would have a bunch of squares drawn with the length of their sides here, and if we draw a whole bunch of them, we will have the volume of what we're looking for. Now remember, dx will be your thickness of this graph. If we're thinking about the boundaries, the sections are perpendicular to the x-axis, so our boundaries are going to come from the x-axis. Okay, remember, the 2D shape here is the circle. If it's perpendicular to the x-axis, our boundary, A and B, come from the x-axis. So where does the circle end up or begin and end? From -2 to 2. So for our boundary, or our integral, it's going to go from -2 to 2. So that's one of the easiest things to do. Our boundary comes from whatever it's perpendicular to, that will be the axis that we're looking at for our boundary. And it comes from the 2D shape that we've got the equation for. So that goes from -2 to 2. So our volume equals the integral from -2 to 2 of the function. Now, this is a square, okay? So we know that in a square, this side times this side. So what we need to do is find an equation for this side. Now let's think about that. If this circle has the equation x squared plus y squared equals 4, and the cross-section are perpendicular to the x-axis, well, if its cross-section is perpendicular to the x-axis, we have to solve this thing for y. So I'm going to get y by itself. I get y equals the square root of 4 minus x squared. What that means is, if this is my x value, then wouldn't this right here be my y value, because we go right x up y? Well, if this is what y equals, then wouldn't this portion be the square root of 4 minus x squared? Well, that's only half of the side of my square. So in order to get both sides of the square, I'm going to have to multiply this by 2 to give me this entire side. So the side of my square is 2 times the square root of 4 minus x squared. Now understand, this is one side of the square. To get the area of this, I have to square it because it's side squared. Side times side, length times width. All right, so to get the area of the square, I am going to take this and I'm going to square it, because if this is the side, the area of a square is side squared. So that area formula for the square is going to go right here. So that would be 2 times the square root of 4 minus x squared, and that whole thing is squared. So here is my setup. The volume is equal to the integral from -2 to 2 of 2 times the square root of 4 minus x squared squared. Understand the dx represents the thickness of the rectangle. And this area represents all of the area in here. Going from -2 to 2 enables us to take all of these thicknesses, all of the squares that can be added together here, to give us the volume of the entire shape. So all we have to do here is integrate. Okay, so I've got the setup here. I have integrated it. You can check it with your work. The volume here is 128/3. Okay, in this one it says find the volume of the solid whose base is bounded by y equals 1/8 x squared and y equals 4. If the solid is formed by semicircles perpendicular to the y-axis. So we're finding the volume. This time we have semicircles and they are perpendicular to the y-axis. Now remember, if it's perpendicular to the y-axis, then we need to get x by itself to figure out what the length is here. Now, another thing we need to remember is the area for a semicircle. Remember, the area for a circle is pi r squared, so a semicircle would be pi r squared over 2. Now, if you think about it, let's look at the radius. Our radius goes from here to there. So isn't that the length that we need to find in order to be able to plug into our area formula? If you think about that, wouldn't the radius be the difference from this function to this one? So this function minus 0. If it's perpendicular to the y-axis, we have to solve it for x. So that's the next thing I'm going to do. X is the square root of 8y, right? This length right here is the square root of 8y, because if we take this function, square root of 8y minus x equals 0, we will get this function. Remember, top minus bottom. If we turn our head sideways, remember we talked about that when we were talking about area. So this is my radius. I'm going to plug it into my formula for radius. So my equation here that I'm going to plug into my integral is pi times the square root of 8y squared, right? Square root of 8y is radius, and we square that, and that's over 2. So if I simplify that, my radius is 4y pi, or 4 pi times y. That would be fine as well. And pi is considered a constant, so it might be better to put 4y times pi, but either way it's fine. And so when we integrate this, our volume formula, now remember this one is perpendicular to the y-axis, so our boundaries are coming from the y-axis. Now remember, this one starts at 0, and it ends here at the equation y equals 4. So it goes from 0 to 4, and we have 4y times pi, or 4 pi y dy. So we've got our area formula here, and we're going to take the integral of that and solve it. Now you might be asking yourself, in the last one I had to go all the way across, so I had to multiply this by 2 to get this entire length for my square. But think about what you need for the area formula of a circle or semicircle. We only need the radius. That's why we didn't have to multiply that by 2. That's the radius. That's the portion of that semicircle that we need. So that's why we didn't have to multiply it by 2 to get the diameter. Okay, so I wanted to make sure I pointed that out. All right, so I'm going to integrate this. So when I integrate, it's a very simple integration. I end up with 2 pi y squared, going from 0 to 4, which ends up giving me a 32 pi for my volume. For this setup, it says find the volume of the solid whose base is bounded by y equals x plus 1 and y equals x squared minus 1. So this would be the x plus 1 line, this would be the x squared minus 1 line. And the cross section is perpendicular to the x-axis. So if it's perpendicular to the x-axis, we need to solve our equation for y, which they are solved for y. So that makes this one a little bit easier. And we're talking about cross sections being rectangles with a height of 5. So they gave you that this is 5. What we need to figure out is the other length of our rectangle, which would be right here. Now, if we think back to the area between two curves, or the distance between these two curves, wouldn't it be the top function minus the bottom function to give us this height right here? So our top function we said was x plus 1. Our bottom function, x squared minus 1. We're going to subtract those two from each other to figure out what this length is. So x plus 1 minus x squared minus 1. So if I subtract those two, I've got x plus 2 minus x squared. If you think about that, x doesn't have anything to subtract, so that just comes down. 1 minus negative 1 is 2, and then a minus x squared. So this is our distance here. So that is the length of this side of the rectangle. Now think about the formula for the area of a rectangle. Area equals length times width. All right, our length is this right here. Our width, they gave us, is 5. Giving us our area formula of 5 times x plus 2 minus x squared. So to set up my integral, let's think about the boundaries. If its cross sections are perpendicular to the x-axis, our boundaries come from the x-axis. So we need to figure out where this x value is, and this x value, we know that's at 2. Okay, so how would I figure out where this x value is? Well, aren't we looking for where these two functions intersect? Couldn't we set these two functions equal to each other and figure out what that x value is? So I'm going to set them equal to each other. X plus 1 equals x squared minus 1. And if I solve that, I'm going to get it equal to 0. So I'm getting x equals 2 and x equals negative 1. So that, we knew this was going to be 2. We didn't know that was going to be negative 1. So those are our boundaries. So our volume is going to be equal to the integral from negative 1 to 2 of the area formula, which is this right here, and I went ahead and distributed the 5, and our variable of integration is dx, so we need the dx to represent the thickness. So here's my setup. You can go through and solve that if you'd like. Make sure you're getting right. I would go through and do a few of these. Just pause the video, make sure you're getting them right, make sure your integration is okay, and then I would go ahead and check them on your calculator. Get in the habit of using that calculator to check, because on the AP calculus test, you may be able to use you will be able to use the calculator on half of the test. So, once you get the setup here, you don't want to do them by hand. That wastes time. So get in the habit of checking it on the calculator as well, so that you're used to how to operate that calculator doing integrals. So the answer to this one is 22.5 when you do the math there. I'm trying to do one of each type of common shape just so that you can see them. This one says find the volume of the solid whose base is bounded by the circle x squared plus y squared equals 4. The cross sections are perpendicular to the x-axis. So perpendicular to the x-axis means we have to solve this thing for y. And they're equilateral triangles. Okay, equilateral triangles. That's a formula that I was not familiar with until I started teaching calculus. So that is one you're going to have to memorize to make sure you have it in your knowledge for the AP test. because I have seen sample questions with that on there. So make sure you do that. The area formula for an equilateral triangle is area equals, and this was on the first slide, the square root of 3 over 4 x squared. So that's the formula you're using. Cross section is perpendicular to the x-axis. We've got to solve this thing for y. That's the same one we solved for earlier, so I'm not going to show any work for that. We've done that once already today. So that is what y is equal to. X is going to be the base of the equilateral triangle. Now, these are supposed to be equal. They don't look equal in my picture, but understand there's no way I can get them all perfect. If this is this length, right, because it has to span the base of that triangle is our x. Each one of these is x. Well, the base is both of these things. Now, if you think about what this means, if we go right x, up y, this length right here is this. So we have only accounted for half of it, is what I'm getting at here. So we need both sides. So that means to get this entire length, don't we have to multiply y equals square root of 4 minus x squared by 2? So our x value for our formula is going to be 2 times the square root of 4 minus x squared. So if I plug this into my formula here, I have the square root of 3 over 4 times 2 times the square root of 4 minus x squared squared. So we're going to square all of this, and this is what I'm going to end up with. So when I simplify that area formula, this is what I get. So this is what's going to go in my integral. So my integration, now think about the x boundaries on that circle. They're going from -2 to 2. So here's my setup. Volume equals the integral from -2 to 2, that's the boundary on the x-axis because it's perpendicular to the x-axis, of square root of 3 times 4 minus x squared dx. I can move that square root of 3 outside before I integrate. Once I have done the integration, and solved this thing, my answer ends up being 32 square root of 3 over 3, which is approximately 18.475. Again, if you round, that's fine. Just make sure you round to whatever they ask you to round to in the directions. And I would guess that the calculator, if you do it on the calculator, is going to give you a decimal. Probably not this. This one says, find the volume of the solid whose base is bounded by the circle x squared plus y squared equals 4. The cross sections perpendicular to the x-axis are right isosceles triangles with a leg on the base of the solid. Okay, so the volume or the area formula, you need to know the area formula for a right isosceles triangle. Now this would be your x here within the formula. So my area formula for an isosceles triangle is x squared over 2. And this is perpendicular to the x-axis, so that means we have to solve it for y. We've done that a couple times already. So we already know that y is equal to the square root of 4 minus x squared. Now, keep in mind, this length is the x in your formula here. So this is what we have in the formula. So don't I need 2 of them to get the entire length? So this entire length is 2 times this, and that's what I would put in here. So this length is 2 times this length. So what I put in for x here is 2 square root of 4 minus x squared. So my area formula of the right isosceles triangle is 2 times the square root of 4 minus x squared squared over 2. So if I square the top, the area formula is 2 times 4 minus x squared. I could distribute that. That's what goes in my integral. So my volume formula, the setup, this is my area formula. I've got dx to represent the thickness of the isosceles right triangles, and it's the same circle. It's perpendicular to the x-axis, so my boundaries are taken from the x-axis. It goes from -2 to 2. When I solve this one, if I do it by hand, I'll get 64 over 3. If I do it on the calculator, it's going to give me 21.3 repeating. Again, you would round however the directions are telling you to round. And again, you could solve it by hand to make sure you're getting your integrals correct. It doesn't hurt to practice that. So I've got 3 examples for you. I want you to set these up and go ahead and integrate them on your calculator, and let's make sure you've got what you need. This one says, given the graph bound by the equation y equals 3/4 x minus 3, x equals 0, and y equals 0, find the volume of the figure if the cross sections perpendicular to the y-axis are semicircles. So you need the formula for the area of a semicircle. That area equals pi r squared over 2. This one is perpendicular to the y-axis. If it's perpendicular to the y-axis, That means you need to solve the equation for x, and your boundaries will be on the y-axis. So go ahead and pause the video, see if you can set this up, and then I'll come back in a few minutes with the answer. So here I've got this problem worked out. Notice this, the length from 0 to this function is the diameter of the semicircle. We need the radius. So once we figure out what this length is, we do need to divide it by 2. So if we need to solve this equation for x, I did that right here. 4/3 times y plus 3 equals x. That's our diameter of the semicircle. But we need the radius of the semicircle, so I'm going to divide this by 2. Well, I can do that if I just multiply the 4/3 by 1/2. That's the same thing as dividing by 2. So that would give me 2/3 times y plus 3 as our radius. We know the formula for the area of a semicircle is pi r squared over 2. I know now that my radius is 2/3 y plus 3. And I need to square that radius. I put this 2 underneath pi, made it pi over 2. I squared 2/3, making it 4/9. And y plus 3 squared, I just leave as y plus 3 squared. I'm going to put this in my calculator anyway. When I multiply these two together, I get 2 pi over 9 times y plus 3 squared. That is my area formula. That's what I plug beside the integration. And when I do that, I can put the 2 pi over 9 on the outside because it's a constant. So my volume formula is 2 pi over 9 going from -3 to 0 of y plus 3 squared dy. When I put that in my calculator, my volume is 2 pi. Here's the next one. It says, find the volume of the solid whose base is the region inside the circle x squared plus y squared equals 9 if cross sections taken perpendicular to the y-axis are squares. All right, so the formula for a square is side squared, right? So one side of a square, and they have it drawn here. It's hard to see it. They have a little square here. So one side of the square would be this section right here, or well, this would be half of a side of a square. So the whole thing would be this right here. So whatever we get for this, we would have to multiply it by 2. If they're taken perpendicular to the y-axis, we need to solve this thing for x. So you're going to solve it for x. Our boundaries are taken from the y-axis. That would go from -3 to 3. And the formula, again, is area equals side squared. So go ahead and pause the video, see if you can get this one. Solve it on your calculator, and I'll come back with the answer in a few minutes. So here's the answer to this one. It says it's perpendicular to the y-axis, so that means we need to solve this equation for x. So we have x equals the square root of 9 minus y squared. That means this length right here is the square root of 9 minus y squared. So that means the length of the side of the square would be twice this. So the side is 2 times the square root of 9 minus y squared. Our formula for the area of the square is side squared. So we have to take this and square it, which is 2 square root of 9 minus y squared squared. That is the area formula that I put in my integral. Now, when I square this, I end up with a 4 times 9 minus y squared. I bring the 4 to the outside. I've got the 9 minus y squared behind the integral, and that's what I'm going to integrate. My boundaries go from -3 to 3. Those are on the y-axis because it's perpendicular to the y. And then when I integrate, I did that on my calculator. I ended up with 144. So here's the last one. It says find the volume of the solid whose base is the region bound by the lines x plus 4y equals 4, x equals 0, and y equals 0. If the cross sections taken perpendicular to the x-axis are semicircles. So we know that we've got semicircles drawn in here. The diameter of the semicircle is this equation, x plus 4y equals 4. Now, it's taken perpendicular to the x-axis, so we do need to solve this for y. We need to get y by itself. And then we know that y is the diameter of this, so we're going to have to divide that function by 2 to get the radius. Go ahead, pause the video, set this one up, solve it on your calculator, see if you can get it, and I'll be back in a few minutes with the answer. Okay, here I've got the answer for you. So the radius is half of this y value. So if you get y by itself, you end up with 1 minus 1/4 x. That's the diameter, or 2r. So the radius of that diameter, or the radius of that semicircle, is going to be this divided by 2. So if I divide 1 minus 1/4 x by 2, I get 1/2 minus 1/8 x. That is my radius of the function. I then plug that into the formula for the semicircle, or the area of the semicircle, which is pi times r squared, this being r. I have to square that and divide the whole thing by 2. When I do that, I just made this pi over 2 times this squared. This is the volume, or this is the area formula that I'm going to put behind my integral. So here it is. I put the 1/2, or I put the pi over 2 on the outside because it's a constant. And my boundary goes from 0 to 4. This says it's perpendicular to the x-axis. The x boundary goes from 0 to 4. If we're talking about the region bounded by this graph, x equals 0 and y equals 0. So this is the region bounded. See, I've got lines drawn here so you see exactly what we're talking about. And when I integrate this on my calculator, I end up getting pi over 2, or 1/2 pi. So that's it. You're going to have some practice on these. Most of the practice is going to be perpendicular to the x-axis. There will be a few maybe perpendicular to the y-axis, but most of the time the formulas that you see for this, or the problems that you see for this, are taken perpendicular to the x-axis. So that's what we're going to do the most practice with.